Hi everyone and welcome to my new course in the field of scientific computing, OpenFoam Practical Guide. This course is designed to help anyone interested in computational fluid dynamics and OpenFoam in specific, which is a powerful open source tool widely used in the field. The course will be hosted on YouTube, making it freely available to anyone who is ready to explore new tools and expand their skills in scientific computing. In this introduction video, we are seeing the structure of the course and what you are expected to learn. By the end of this course, you will get to know what OpenFoam is and why you should, as an engineer or a scientist, have it in your setup. Then, we explore the structure of OpenFoam source code and you will learn how to start your own CFD project. I want to say that learning OpenFoam helps you really understand CFD. Unlike many black box software that shield you behind a nice UI, automating processes without revealing the inner workings. On the other hand, OpenFoam puts you in control of every step you take. You will not only use the tools, but also learn how and why they work the way they do. Therefore, in this course, we will step away from black box codes and explore OpenFoam, where we run and control our simulation using a terminal and a text editor, interacting with the code at its core. This hands-on approach will give you a deeper understanding of CFD and the tools you are using. It's a bit more effort for sure, but trust me, it's worth it. To achieve the objectives of this course, I have divided it into 4 segments. Segment 1, where we start with the installation of the source code, then understanding the structure of OpenFoam in general and OpenFoam case in specific. Then we end this segment by knowing how to run and control an OpenFoam case. In the second segment, we talk about pre-processing in OpenFoam. Things like creating a computational mesh using OpenFoam utilities, especially block mesh utility. Also, we get to know what is the different boundary conditions that are available in OpenFoam and how you implement them. In the third segment here, we discover one of the essential components in OpenFoam, which is solvers. The solvers in OpenFoam used to solve the equations following a specific algorithm. And segment 4, here we are performing some basic but essential post-processing analysis using mainly ParaView software. As you see, the content is presented in a carefully chosen sequence to not cause any confusion to new users. Therefore, it's recommended that you start with the first segment of the course and follow through to the end, as it's presented as a story with a beginning, middle, and end. What you should have to take this course? You just need 2 essential things: computer and a cup of coffee. But if you like perfection and want to approach it, so some basic knowledge of CFD, programming, and Linux will be beneficial for you. You will need a CFD knowledge to have sense of what we're actually doing here and why we are doing it this way. And a programming background may be needed, for example, if you have some curiosity to read some of the source code files to see how powerful and well organized OpenFoam is. And if you would like to modify or create a new solver or a library, you will need a programming language skills. But we are not doing this here. We just will use the default solvers that come with OpenFoam without any modification to it. We will just use them as they are. So programming is not a required thing. So what about Linux? Why? Why Linux? Because actually OpenFoam is developed for Linux operating system. Therefore, to use OpenFoam, you need the Linux operating system. Fortunately, it's possible to create a Linux-like environment inside Windows or Mac OS to use OpenFoam. So, if you don't want to change your operating system to a different one, you don't have to do so. But you still have to learn some essential Linux commands that are needed to perform the tasks in the Linux environment. You will find all the Linux commands needed in this course written in the course notes, so you can always check them as needed. Before we dive in, it's important to understand what OpenFOAM is and what it can do. First, you might wonder, what does FOAM stands for? Well, FOAM stands for Field, Operation, and Manipulation. The field part highlights that OpenFOAM is used to solve for fields like velocity, pressure, or temperature, and so on. And what about the word open? It simply reflects that OpenFOAM is free and open source software. Here's some information you should know about OpenFOAM. It's a free open source code, meaning anyone can access, use, and even modify it to fit their needs. It's used in computational continuum mechanics, written in C++, and based on the finite volume method. I support that. Before learning OpenFOAM and dive in, it's good to know what kind of physical phenomena you can solve. And actually, OpenFOAM is multi-purpose code, so it can be used to solve different problems, things like compressibility, turbulence, heat transfer, and more, as you can see in this list. Thanks for watching. In next video, we will dive into the installation process for OpenFOAM. See you there.